Hi everyone, Krishna this side. So in this video, I'll be covering this lead code problem 1751, maximum number of events that can be attended. Second, okay. So let us try to go through the problem statement quickly, and then we will discuss about the approaches. You are given an array of events where events of I equals to start day, end day, and value. This is the array it has been given. The ith event starts at start day and ends at end day, and if you attend this event, you will receive a value 1. Okay. So you are also given an integer k which represents the maximum number of events you can attend. All right. So these values are given to us. Now you can only attend one event at a time. If you choose to attend an event, okay, if you choose to attend an event, you must attend entire event. All right. So note that the end day is inclusive. That is, you cannot attend two events where one of them starts and other ends on the same day. Okay, so yes, I mean any events that we are actually attending, we should attend entirely, and in between we cannot switch to another event. Okay, that is what it is trying to say. So it is asking like return the maximum sum of values that you can receive by attending events. So whatever the values that we are collecting by attending them, so when we add all of them attending different events, whatever the maximum answer that we get, that is something what we have to return ultimately. So let us see in the first example, the events are like 1, 2, 4. That is the first, and on second day, there is a event which is having value 4. So in this event image also, it is pretty much clear. So on first and second day, there is a event 0, which is having 4 value. And second and third day, there is a event which is having 1 value. And third and fourth day, okay, third and fourth day, there is another event, okay, which is having value 3. So yes, we have k value as given 2. So we can attend 2 events at max. So if we try to attend the first event, on first and second day, its value is 4. Now I cannot attend this second event, right? Because it is actually overlapping with the first event on the second day, correct? So this event we cannot attend it. Next event we can attend is like third event. So whatever this event 1 we can attend, okay? This event particularly we can attend. And its value is basically 3. So yes, collectively if we try to attend these two events, the value overall is basically goes to 7. What if, are there any other possibilities apart from this? So yes, we can just only attend the second event, because this second event is basically getting overlapped with first as well as second. Yeah, this event 1. Okay. So yes, if we try to attend this, we cannot attend this event 0 as well as event 1. So in overall, if we try to consider this value, so it is basically 1. So yes, the output that we got from the previous one by attending 0th event and first event was actually maximum compared with this one. So yes, we have to consider the maximum output. Okay, so we attended 2 events, as in the range is also basically given. So yes, that is the best answer that we can get it. Okay, so question is clear. I think let us try to see directly on the screen how we can approach this one. Let us say that this is the example given and k value is basically equals to 4. 4 events we can attend at max. Okay, below that also, if maximum answer we are getting it by attending few of the events, that is also uh, considerable. Okay, now here it is like start day. This is the start day, end day, and this is the value that is been given. Okay, for all different events. So now first thing that comes in our mind is, let us try to sort this array, right? Because if we do not sort the array, the problem is like we have to figure out what is the next event, because if the data is not in a sorted order, definitely it will be a problem to figure out which element we can attend next. Okay, so best is like if we sort the data, once we finish any event, we can actually easily figure out like next event could be possibly from this given. If we start looking for further ahead, there could be a chance that we can get the next event by attending this particular one. Okay, so yes, the first thing is like we will sort the data. Now the moment we sort data, let us suppose this is the array that we have. Okay, and based on the values, like the data has been actually available right over here. So all the events that basically starts with 1 are right over here. Then next is like 3, next event basically starts with the 3. Okay, so based on the start time, we are basically sorting the data. Okay, based on the start date. So now the data is basically sorted order. So the first thing is like we will start picking the elements, right? So let us suppose if we pick this one, first element, so its value is basically equals to 4. So the answer is basically, so far we are getting 4. Answer is basically equals to 4, and we picked this element, this event. So if we choose this particular event, which is basically starting at the first day and going till 5 day, fifth day, till fifth day it is basically going. Okay, its value is basically equals to 4. Now next is like, if I have chosen this one, of course whatever the next event that I am picking, it should be from the sixth day. Okay, whatever the events that basically we are planning to choose, it should start from the sixth day. In between any events that are coming, we cannot consider it, because this is something what we have picked right now. Okay, so yes, if we choose this particular one, we cannot choose any events that are basically coming inside this one. Okay, any dates that are getting overlapped with this particular events, we have to ignore them, because we have chosen this particular one as an answer. Okay, so yes, that if that is the case, now we have to figure out which is the next element that will be actually greater than this 5, right? Because 5 days we actually completely blocked with this particular one. Now next event basically should start from the sixth day onwards. Okay, so this event is basically starting at first day. This is not answer. This event is basically start at third day. So third day is basically somewhere here. So also it is also overlapping event for this one. So this is also not an answer. This event, if we try to say, it is like starting from the fifth day. So yes, again it is like overlapping, because on the same day we are finishing this one. Okay, so this is also not the next event that we can consider if we consider this one. Okay, get great. So far we are good. Now okay, this all three events are not possible. Now if we look here, it is like starting from the seventh day. Okay, from the seventh day. Okay, seventh day, and it is going all the way till the ninth. So yes, this is something what we can choose if we have picked this particular one. Now next event, something that we actually are trying to looking out for is like this one. Okay, 7 to 9, and its value is basically equals to 6. Okay, so previously answer was 4, and now this is like 6. 4 plus 6 is new answer that we got. Okay, now the moment we choose, next event is something what we have to figure out. Okay, so next is like again this 7 to 9 is something what we have got. So next is like 8 to 9. So again 8 is basically getting overlapped here, 8 to 9, and its value is basically equals to 12. The problem is, since we have chosen this, we cannot pick this one. Okay, we cannot pick this one. But what if we do not consider this one? What if we do not consider this one? Definitely with this particular event, if we consider this one, definitely the answer is better, correct? So 4 plus 12, if we do, it is going to give 16. This was basically 10, right? So this was the best answer that we got. So here comes an idea that, okay, we have the choices. Either we can pick that event, or we can skip that event. Okay, either we can pick that event and we can skip that event. If we pick that, okay, whatever the event that we pick, we have to figure out the next event. Okay, whatever the end date that we have, let us suppose here the end date is 9. Okay, for this particular event. Okay, for this particular event the end day is 9. Okay, for this one end day is 9. So next, from this array, from starting from this particular index, whatever this index, it was index, let us suppose I is this index, from I plus 1, so on, whatever all the elements that we have in the events array, we have to figure out the next event that should be starting from the 10 or greater than this 10. Whichever the event that is basically starting from 10 or greater than that, that is something what we have to figure out from this array. Okay, or if we do not pick this one, if we do not pick this one, definitely whichever the next event that we are looking out for, it should be actually greater than this 5, greater than this 5. Okay, that is the simple idea that we are trying to do right over here. Yes, the easiest thing that we got to know is like, either we can pick this one or not pick this one. Now same idea that we will apply. So this first event is something what we will not consider right now. Okay, if we do not consider this event, our start day is basically still day equals to 1. That is something what we have currently. Okay, so this is like again new event that is come in our account. So here also we can either consider this or we can skip this event. Okay, let us suppose we consider this event. So its start date is like 1, end is basically 2, and its value is basically 3. Next event is basically 3 and 4. 3 and 4 is the event that we have, and it is basically getting overlapped. Okay, because here it is starting with 1, sorry, it is ending with 2, right? So this particular event is basically starting with 3, starting with 3. Okay, starting with 3 and ending at 4. So its value is basically equals to 2. Okay, so yes, this event also we can consider. Okay, here also there are options. Okay, we can consider this one or we can skip this one, because we have seen that going ahead for this particular example, right? For previous example, when we pick 1 and 5, if we choose this one, there is a high probability that there are further events that may be getting overlapped, and if we consider those events with this current event, definitely that could be a best answer. Okay, so yes, there are possibilities, either we can pick it or not pick it. So here also we will do same thing, either we will pick it or no pick it, even if it is not getting overlapped. Okay, even if it is not getting overlapped, still we have to pick it or not pick it. Okay, those options will there for each and every index that we are trying to process. Okay, the idea is pretty much clear. So yes, we have choose this one. So here we have two options, either we can skip it or we can pick it. Now once we pick it, again the next index for this after 3, which is the next index that we can choose, that is something that we have to figure out. For 3, next index, sorry, it was 2, right? 3 is basically the value that we have. 3 is the value that we have for 2. Next index is something what we have to figure out, because if any index getting overlapped below these two, if there is any events that is happening, those events are not considerable, because we have to make sure that any events that we are picking, it should be start with value greater than this two, value greater than this two, whatever this event that we have chosen, next index event that we are chosen, that next event whichever we are picking up, it should be actually greater than this two. Okay, so simple idea, few things we are doing. The first is like we are either picking the event or not picking the event, so it is like 0 on knapsack we are applying. Okay, we are doing operations starting from this 0th index so far till the last index. Okay, so all the options we have, either we can pick that event or not picking that event. Okay, next is like the moment we pick the event, the moment we pick any event, we have to figure out its next index. Okay, next event that we can pick, and next event should be this, whatever the value that is given, the end date. Okay, end date, this end dates, it should be greater than this end date. Okay, because if it is overlapping, those events are invalid for us, right? So second idea is like we have to figure out the next event. Okay, and that event, how we can figure out, let us suppose 5 something what we have here as a end date. Okay, so can we consider this one? Okay, if we try to iteratively go through this, okay, this, is it possible to consider this event, because its end or start date is basically relying in this one for this particular event, so this is not considerable. Next is like this, since the array is basically sorted, so if we start going on like this is also not a considerable event, because this is getting overlapped. This is also not considerable, because this is also again getting overlapped. Its start day is basically 5 and our current events end day is basically 5, so this is also not considerable. Next is like 7. Okay, this is basically considerable. Okay, now here, like if we go iteratively, the complexity is basically pretty much high. Okay, because we are going through all the events that we have, it is like n times we are going it. But the idea is the data is basically in a sorted order. Data is basically in a sorted order, so best thing that we can do is we will simply apply binary search. Okay, so from this, let us suppose this was the, I have created a lot of mess right over here. Let me clean this up. Let us suppose this is the current index is basically equals to I. Okay, and we have chosen this. The moment we pick that event, what we have to do, from I plus 1 till n. Okay, till last index is basically n minus 1. So in this one we have to simply apply binary search to figure out the next event that we can consider after this one. Okay, okay, that is the idea. So now the idea is like from I plus 1 till n minus 1, we will try to figure out the next event that we can choose. Okay, next event, next immediate event. Okay, it is not like okay, this is first event that we got, again this is also considerable event. Here either the moment we got the next event, because this is the next event, right, all these events are not considerable. We will simply apply the binary search and we will try to see whatever the next event start time, if it is actually greater than this one, that is the answer that we will have. So for that we will apply binary search. Okay, the moment we got this one, here also we have two options, because this event is something what we have pick. And here also the moment we come here also we have two options, like we either skip this one or pick this one. If we skip this one, we will directly move to the next index. Okay, so that whatever this index value plus next index value, that is also a probability for us. Okay, those answers are there with us. So if we pick this one, we have to figure out again next event for this 9. Okay, after 9, which dates are there which are basically considerable. So this is like again overlapping, so we cannot consider, and we will be done for here, done for this one. Okay, so that is the idea. So we will first, like we will apply pick or not pick. Okay, so if we skip, next index is something what we have to consider. Whatever the current looping that we are having, I is basically 0, then I plus 1 is something what we will try to loop. There also we will apply pick or not pick. Okay, so same thing happened till the last index. Now the second option is like either we will the moment if we consider we have to get the next index, because going through single each index and seeing whether this is considerable or not, it is like really a lot of time we will consume, and definitely we will going to hit TLE. So we have to make sure that we will apply binary search right over here to figure out the next index that we can get it. Okay, the moment we get the next index, there also we will again keep on applying pick or not pick, these two options. Okay, at the end what we have to do is whatever the answer that we got from the pick or not pick, whichever is the maximum answer that we got, okay, either we can attend it or we are skipping that event. So maximum whatever the answer we get it from the pick or not pick, that is something what we have to consider. Okay, so recursively we will do all these operations. If we pick this one, we have to start from this one and we have to figure out the answer from here. Whatever the maximum answer that we can get it, we'll try to get it. If we do not pick this one, again from here we have to apply the same thing. But if we pick that one, we have to just apply the binary search to figure out the next index. So it is pretty much same, straightforward. If we have done all the 0 1 abstract related problems, you would have easily solved this one. Okay, let me try to write down the code, and after writing the code again I'll explain you what is basically happening right over here. Okay, so very few options that we are doing. The first is like we have to get this length from this one. Let us suppose events dot length. Now we got the length. The next is like we will create a solution. So in the solution, let us pass from the 0th index we are starting, and we will be either picking it or not picking it. And we have to make sure that we are just considering only k events. Okay. So k value also we will keep on reducing. The moment we consider any event, we will reduce the kth value. Okay. So simple, first without DP, we will try to solve this one. So in the iterative way, these are the values that we basically require. So let us write this solution as well. In the solution, first is like the I current index we are at, the k value, and these events. Okay, here the first idea is if this k value, if it is basically equals to 0, that means we are actually got sorted with our limits. Okay, we actually consider all the events that we are basically trying to look out for. Okay, so if k value is basically equals to 0, or this I whatever the current index, if it is actually greater than or equals to this events dot length, okay, at that point in time we will simply return 0, because we are done with this. Okay, this is the base condition that we can have. Base condition, the moment we got the base condition, the second thing is like we will be trying to solve this one. Okay, the first thing is like either we skip this element. Okay, whatever the event that we are having, current event at 0th index, that we can skip it. If we are skipping it, we will simply go to the next event. Okay, so I plus 1 is something what I'm passing right over it. K value we cannot decrease it, because we are not considering that event. If only we are considering the event, k value will get decreased. Okay, events is something what I'll pass. Now the next is like attend this one. So if we are attending this event, okay, so here whatever the events value that we have, the events value is basically available at second index. Okay, so events of I current index, in that second value something what we are picking, and the solution is something what again we will try to get it for the next index. Okay, next index is something what we have to figure out. Okay, I cannot simply go iteratively and keep on checking whether this is next possible solution. Here we can either apply the for loop and keep on checking which is the next index for this one, which that index event that we can attend it. Okay, that we can do it, but iteratively, instead of doing iteratively and again increase the complexity, what we will do is basically we will apply binary search right over here. That will basically happen in a log of n. Okay, that way we can easily get which is the next event that we can attend after attending this current event. Okay, so yes, next index is something what I have to define right over here. So what I'll do is like int next index equals to, here let us write a binary search logic. In the binary search, the first thing that we have to pass right over here is this I plus 1, because from the next index onwards till the last index, what is the next events that we can consider, that is something what we have to figure out. Okay, so that is the limit that we have from the I plus 1 index we are starting, and we are going all the way to the last index. Okay, it is doesn't necessary that to pass this how many elements that we have. So events array, from the event array we are trying to figure out, and yeah, of course, like if I am looking for, let us suppose I have picked this event 0. Okay, from this given example 1, let us suppose I have picked this event 0. Next event basically start from, so the end time of this event is basically second day. So after day 2, After date 2, whichever the date that I am getting it, like either it could be 3 4 from the events array, that is something what I have to pick it. Okay, next event only, next immediate event is something what I have to figure out. Okay, so from the events, this whatever the current event that we are at, current event of I and 1, this is the end time for us. From the end time onwards, whichever the next event that we get it, that is something what we have to figure out. So I pass that end time event as well. Let us try to write this binary search first to get next index. Okay, let me just copy paste right over here. Int, this is like start and events, and then there is like this end time. So we have to make sure that whatever this current events end time that we have, the next event that we are picking, it should be greater than this end time. Okay, that is the simple idea. So the start is here, the end is basically, let us try to figure out, it is like events dot length -1. Okay, in that particular range only we are trying to figure out. Let us decide answer here as well. So answer is basically end plus 1. So whatever, if we are not getting any events, we will definitely reach out the last index. Okay, so last index, whatever the last index that we have, I'm just going out of the bound of the array. Okay, and this answer is something what we have to return at the end. So let us do that as well. Now we will apply binary search right over here. So while this start actually less than or equals to end, okay, we will get the mid equals to start plus end minus start divided by 2. Okay, the mid is something what we have figured out. Now the first thing is like we will simply check that if events of this mid and 0, whatever the mid index that we are at, and 0, that is like the first value. Okay, the first index value. Means like we figured out that particular index. On that particular index, the 0th value, that is like start time, if it is actually greater than this end time, whatever the end time that we have for this current event, in that case we will simply update that answer equals to this mid, whatever the index that we are at, and high is something what we will reduce, high equals to mid minus 1, because the answer maybe now we have to figure out the least one, because the next immediate next index is something what we are trying to figure out. This could be an answer, but yes, immediate next is something what we have to figure out, so high should be less than this mid minus 1, so that in smaller range again we will try to figure out if there are any events that can be a possible answer or not. Okay, so in the else case, if that is not lying from the mid, so again we have to check in the higher range. Okay, mid plus 1 to the last till the last. We will keep on doing this operation. Okay, the binary search is pretty much straightforward. This logic, whatever the logic that we have applied right over here. Now, next index is something what I have passed. For this skip, we will immediately go to the next index. But for this attend, we have to make sure that we will get the next proper appropriate index that we can consider after attending this particular one. Okay, so next index is something what we have to figure out from the binary search. The moment we got the next index, next is like k is something what we have to reduce it, because now here we have attended this event. Okay, so we can max to max attend k events. So this particular, if we attended it, k should be less than this, I mean we have to decrease this k value. Okay, and the moment k is basically equals to 0, we will simply return, because we cannot go further ahead if we attended all the events, that is basically what are the key values been given. Okay, and at last, like I will pass here events, and we will simply return math.max. Okay, whatever the skip or attend from this, whichever the best answer that we got, that is something what we have to return at the end. Okay, so simple I mean recursive approach, that is something what we have right over here, the code that we have written. So okay, there are few of the errors. High, basically it is not high. I have made here end correct, and mid plus 1 start end time. Okay, all things are correct. Left is also, it is not left, it is start. Okay, I think that should be fine. And there are wrong answers as well with this current code. Okay, 14 is something what we are getting it. Let us try to figure out with this recursive only where we went wrong. So we have this k equals to 0, or I basically return this events dot length. We will simply return 0, that is the base condition that we have. Skip, while skipping we will simply go to the next index. Okay, yes, of course we have to sort the array. I just remember that arrays dot sort this events. Okay, if you do not sort this array, definitely we will not going to get the best answer, because the binary search logic is something what we are applying it, and we have to make sure the next event, whatever we are picking up during the skip as well, it should be immediate of this one. Okay, so yes, for all these operations we will sort it based on the start time. Okay, the moment we sort the array, we will be trying to get it recursively, and next event, for the next event, I plus 1 is the index from where we will be looking at events, and this event of I 2. Okay, these are all things correct. At end basically equals to solution k minus 1, next index, and k minus 1. Okay, I think this is correct. Let us try to run it again and see if it is working fine or not. Okay, all test cases are getting accepted, but the problem is, of course, since we did not apply here dynamic programming DP, we will definitely going to get hit with TLE, because we are keep on trying to build the same answers again and again in the event further. Okay, there could be a possibility that at particular index, whatever index we are at, and the k value that we might have figured out previously as well, and that is something what we are not considering it. So of course it will definitely going to get TLE. So what we will do in that particular case, we will define here a DP array, and in the DP array, the events dot length. I think I should have taken this n. Okay, n is basically there, right? So why I'm considering it, n is there, and this k plus 1 is something what we have to consider, because in the DP, k is basically whatever the k value has been there. Let us suppose 3 is value that we have, so DP of 0 3, that could be an answer. Okay, we have to make sure that we will be considering DP array with k plus 1. Now here we can fill this array. uh, Let me just apply this. Okay, what was that? Arrays dot it, I just forgot all the stream APIs. Let me just write it recursively. Int idx from this events. So simply whatever the arrays I'm getting it, arrays dot fill idx comma minus 1. Okay, so yes, all these values basically we are filling it with this minus 1. So it should be DP array. From the DP array, whatever the index that we are getting it, we are filling it with minus 1. Okay, I guess this is pretty much fine. And we will make sure that here, if this particular event dp of I and here k, if it is not equals to minus 1, we will simply return it dp of I and k. Okay, at any point in time we are doing this, we have to make sure this dp state is also getting updated at any locations. Okay, so dp of ik basically get updated with the maximum value that we are getting it, either skipping or not skipping at that current index. Okay, so yes, that's how we can apply the dp as well. Let us try to see if it is working fine or not. Okay, okay, it should be dp, I guess. That should be the last dp of, yes, I mean we have to pass the dp array as well. So int dp, and here in all the solutions, whatever the solutions that we are defining, let me just consider the dpa here. Okay, I think that should be fine now. Let's see if it is working fine or not. Okay, all test cases are getting passed, and let us try to submit the code. Okay, if you get this, it is fine. If you're not, let me just quickly again walk you through another example. Others can drop out. So talking about the complexity, since we have used dp and we basically reduced I mean whatever the time complexity that we are trying to get by just memorizing it. Okay, so yes, if we consider the space complexity, it is like n cross k plus 1. Basically sorting the data basically takes n log n. Okay, n log n. So sorting should take n log n, and this space is basically n cross k. And after that, this solution, if we consider right over here, we are skipping it or even we are attending it. But since we are basically memorizing the data, it is like n cross k is something of the complexity that we get. And again, to get the binary search to figure out the next index, it is like n cross k cross log n. Okay, that is the complexity that we will get. Okay, so yes, that's all from this talking about this complexity and all. Let me try to walk you guys through another example with recursion tree. Okay, how these things basically working. If others got this one, they can drop easily. Okay, so now let me try to connect this, and let me try to again run the script. Okay, let us suppose same example. I'll just pick 154. It is like 154. Next one is like 1 2 3, 1 2 3, and it is like 3 4, let us suppose 2, something like that. We have 5 6 1 is something. The next we have 5 6 1. Okay, and 7 9 6, 7 9 6. Last one is 8 9 12. Let us suppose that is the array. It has been given to us. These are the events we have, and k value is basically equals to 4. So at max 4 events we can attend. Okay, the first choice is we will start from the 0th index. I is basically equals to 0. We will start from this index. So we have two options. Either we skip this one or pick this one. Okay, if we skip this, so index is basically I plus 1, I equals to 1. Okay, for starting from this 1 5 4, we have two options. If we skip this one, I is basically 1, k is basically 4, same k value, and event array is something what we have. Okay, we are at this index, and value is basically from here, the value is 0 since we have skipped. But here if we consider this value is basically 4, 4 plus the recursive call is something what we are doing it. We have to figure out the next index by applying the binary search. We are doing it. Okay, so this is if we start applying the binary search from the I. Okay, I equals to 1 to n minus 1, we will keep on getting the mid index. Okay, mid index, when we are getting it, this whatever the value of this, it should be start value should be greater than this value. Sorry, this is not the value, right? This is the uh, okay, this is the value that we have, right? At first index, it whatever the index that we are trying to figure out, it should be greater than this value. Start time, whatever the start time that we have, it should be greater than this end time of this current event. Okay, so yes, if we see this is the mid that we get it. So from this particular array, so if we consider this, compare this 5 with this 5, it is actually equal. So yes, of course, whatever the low basically currently pointing at this one, it should start pointing mid plus 1. Low is currently pointing at this one, and high is basically at the last index. Now again, if we get the mid is basically at this is the index that we get it, 7 9 6. Okay, so again, we will simply check the start time of this one, it is 7, and the end time of this one. So here the start time is actually greater, so answer basically got updated to the low. Okay, answer basically got updated to low. So we actually got figured out. Again, if we keep on doing the binary search, that is the best answer that we got so far. Okay, so yes, we got the index. Now we will jump simply at that index. So it is like first, second, third, fourth index is that we got. Okay, fourth index we are at, and here whatever this k value got decreased, k equals to 3 now. Okay, previously k was 4. Now these two options we have. Again, at this particular first index we have two options. Either we skip this one. Okay, if we are skipping, next index is something what we will get it, 4 and 2. If we pick whatever the value that we have, 3 is the value that we have, 3 plus from the answer of, again we have to figure out the binary search is something what we have to apply. So if we apply binary search for this two, next index is basically 3. Okay, so it is like again from the next index, second and fourth, we can get the answer, second and 4. Okay, the here, sorry, it is not 4, k basically got decreased to 3. Okay, so these 1 and 4, these values that I am representing, these are basically current index and k value. Only these two values are getting modified, index and k value. So yes, those values are only I am considering right over here. Here also this recursive function, any recursive function that I am considering, the index, next index and the k value. Okay, so if we are skipping the next index is immediate to that one. Okay, so for one, next index is 2. Okay, that is something what I am doing it. So if we are considering whatever the value that has been there, that is something what we have to pick, and we have to go for next index and k. Okay, the moment we got these values, now again same thing we are doing it. For here it is like, for this one we are skipping it, so next index is like 3 4. If we are considering this one, so it is like whatever the value that we are having at this second index, it is basically 2. Okay, so 2 plus, we have to figure out the next index. Okay, that is something what we will keep on doing it. So ultimately this recursion tree is basically keep on forming. Okay, either we are skipping it and considering it. The moment we reach to the last index where k equals to 0 or index is basically out of bound, from there whatever the maximum answer that we get it, pick and not pick, that is something what we will return at this particular function. From here, whatever the maximum answer that we get it from this two, 3, 4, and from here, That is something what we will return at this particular index 2,4. It is getting lag, so I am not making this recursion tree, but yes, we have to consider this, because at the end here, from the peak and non-peak, whatever the maximum answer that we are getting it, that is something what we are returning back to the previous function. Okay, that is something what we are returning back to the previous function. So from here also, whatever the maximum answer that we got, peak and non-peak, we return at this particular index, and 3 plus this value is something what we will add. Okay, from here we get any some answer from this side. Okay, it is lagging a lot, man. So yes, again from both the side, we either getting the maximum answer, or we are considering it, non-considering it, right? From any of the side, whichever the maximum answer that you got, we will simply put it at this particular function. Okay, from this side also, whatever the maximum answer that we got, and from here, that is something what we will return ultimately back to the previous function. Okay, so yes, that is the idea that we have from both the side. Whichever the maximum answer that we are getting it, we are ultimately returning it back to the previous function. And that's basically the idea to write this particular solution. I hope you get the idea what we are trying to do right over here. Try to solve knapsack problems. It will be pretty much easy to solve this one. Okay, if you are struggling to understand this particular one. Okay, so it is basically pretty much easy. Either we pick it or not pick it. Those two options only we have with current events. Okay, and that is something what we are utilizing it in the solution. Okay, so yes, that's all from this particular video. I hope you get the idea. Thank you for watching this one. Bye bye.